Okay. So we wanted to close off on a very positive note, which is are we all potentially have issues because quantum computing is coming. And so I'm really excited. Yeah, I'm sure you've already seen all of us on different presentations and panels, so we can skip the introductions. But I'm excited to talk about this because I think it's getting more and more important, both for crypto, but also beyond that in broader internet. And so I'm going to start with a very simple question. What's your time to quantum? And I define time to quantum when you can, let's say, decrypt Satoshi's key, private key within some reasonable time of like a month or so.
Like individual consumers can do it, or
no,
like
somebody can do it. Somebody can do it.
Okay.
Okay. 50% probability 2030, 75% probability 2035, 100% probability 2050.
I'd probably go on the lower bound there, more like 5 years kind of thing, before China or the US can probably have well enough working quantum computers. I think probably like 15 years were like before they enter the mainstream.
I think the 50% 2030, and then maybe 75% 2031, and then 90% 2032.
All right, so we're 50% chance in, I guess, 5 years on average. So within that, I mean, one premise I want to kind of to tell everyone, right? Right now, we're all using encrypted internet, right? We go to websites, everything gets encrypted. We use, signals or telegrams or Kakao, and everything is encrypted. But all of this goes on regular internet. Packets are getting routed, and all of that effectively gets spread out all over the world. And so a sufficiently incentivized organizations can be capturing all that information and storing it for future use when they'll be able to decrypt it. And so I'm kind of curious to start this with a Q, which is, do you think this is already happening? Do you think that there's an ambient collection of encrypted material that's happening on the internet? And what are we going to do with that? Because if in 5 years, effectively, all of our information will get decrypted, that's maybe not a great for social liberty and freedom.
I think for government actors, I mean, harvest now, decrypt later is an expensive strategy. You've got to the data volumes are large, unless you're being very selective around where you were doing. So I'm sure people have been doing this probably for the last 20 years. They've been harvesting data from networks that they thought were interesting. But now I think that the potential window in which because you're like, okay, what use is a 20-year-old secret? What use is, we have some people's private communications from 20, 30 years ago. It may or may not be relevant, and how much money do you want to spend collecting, storing this stuff? As the window to decryption starts to seem something that's imminent, now your incentives are skewed more towards collecting more because you are more confident that that will be relevant, useful, actionable intelligence when you are able to decrypt.
I mean, this has always been my big worry with, for example, things like Proton Mail, that governments are just going to end up storing most of the encrypted email traffic that exists just in the hopes that at some point they can decrypt it. But it's actually a good point that my 20-year-old emails are probably not as relevant anymore at this point as my 1-year-old emails. I don't know, but also storage has become very cheap. And so we've seen crazier things. I mean, we should just think back about the Snowden days. People have been doing crazy things, so I wouldn't put it past it that some very incentivized actors are currently storing essentially all encrypted traffic.
Yeah, if you're whatever any government would define as a person of interest, almost certainly that data is collected and stored somewhere with the express intention of decryption at some point. But I think we also often get confused where we assume that the policy implementations of government represent the general efficiency of government. Like, there's a lot of like political side and road building stuff that we think government's incompetent on, but when it comes to like defense architecture systems and information systems, they're quite competent. I mean, if you go and read about some of the work that was done in sort of like 2004, 2006 around database structures for aerial drone surveillance in like Iraq and Afghanistan, they had, you know, petabytes per day of footage that they had to figure out how to store and compress, and they ended up basically building systems where it tracked only movement and threw all the rest of the data away, and that became back-testable systems where they could say, oh, there's a suicide bombing here, where did the person come from, and then they would go like raid that house. And so that was like a pretty incredible like technical achievement in 2004. And so when we think about like the relationship between these things nowadays, I think it's quite likely that there's quite good signals intelligence on, if not what is in this particular Proton Mail email, that we should save this one for later. And so you can actually, it's just like in high frequency trading where 99.999% of the data is noise, and the magic is, can we actually pull out intelligence in 4 clock cycles and make something happen on it? Those same structures are almost certainly being applied at intelligence levels. So, yeah.
Okay, so now effectively we're saying a lot of our data, I mean, maybe we're not hopefully people of interest for government organizations, but a lot of this ambient data is either stored or selectively stored based on kind of relationship to interests. Quantum is coming, so they'll be able to start decrypting SSL certificates, kind of all the keys, and what are we going to do about that? And so my premise is like, is this justifies blowing up all the data centers?
Well, maybe. Arguably, like, I think in crypto we shouldn't delude ourselves that like we may be the first people to experience this, but I would also argue that like if you actually have a working quantum computer, you should go after banking certificates and after the SWIFT network. And I'd be much more worried about like their capability to upgrade this quickly than actually the blockchain's industry's capability to upgrade these systems quickly, because frankly, even if we think ourselves slow, we are still light years faster than how SWIFT and traditional banking gets upgraded, right? So I think we still have some time until we have to really panic. Like when SWIFT panics, we should start panicking too, essentially.
But I mean, SWIFT can just shut down. They can be like,
but then you collapse global finance. Like,
No, well,
they'll just use blockchain.
but they can just
Quantum,
kill
the bull
their
case.
accessibility on the internet. Like the power of like a banking system is you can firewall it.
you have a lot of participants, and like you have to then start trusting all your participants. Which I mean, we've seen these crazy hacks right in Thailand, where like banking employees get hold of the SWIFT signing keys, and then like 70 million bucks is just gone irreversibly. Where everyone's like, oh, the banking system can reverse your transactions, so don't trust blockchains. And just turns out the banking system also can't reverse stuff. Coming back to the original, right, like blowing up data centers. I don't know. Let's hope the data's not that relevant anymore in 10 years.
Yeah, I don't know that we know where the data centers are that are storing all of this data. But I mean, I will say that one thing that seems to have gone very well is the National Institute for Standards and Technology in the US has done this standards process for quantum-resistant post-quantum crypto. And that seems to actually have been like a huge success because like the major internet vendors are all rolling out post-quantum hybrid systems in a lot of different ways. It's actually quite impressive. Basically until December 2024, I was in the there's a 1% chance of a quantum computer that breaks cryptography in my lifetime. That was my viewpoint until Project Willow happened, and then I was like, oh, okay, this is happening.
So yeah, I guess we're going to touch on crypto, but I think for the internet overall, because the thing is like it doesn't matter what we do with crypto if internet is not secure.
Yeah. So There is this thing that's happened over the course of, like, call it the last 100 years, where you see society's tolerance of things that used to be shameful going up pretty well correlated with our observability technology. That you see, like, photography starts getting introduced, and suddenly, like, not everyone's wearing a suit every time they go outside the door, because, like, you have this inverse relationship between how likely is it I'm going to be photographed and the comparative impact of that. Like, US politics is just a clear example of this, where you have so many members of Congress or even staffers doing things in public that would have been inconceivable a few years ago. And I think in part that's due to observability. And so we may get to a place where, like, yes, the financial data has to be secured, and that's a separate issue. But if we're worried about embarrassing emails or embarrassing photos or videos, like, we already live in that world. And like the amount of public response to something 3 or 4 years ago, even relative to now, is much less. Stuff that politicians resigned for 10 years ago is, like, not even really worthy of mention nowadays. And so there is a other possibility, which is, like, the idea of things we consider now being embarrassing, being exposed. Society just moves past that by the time this is all actually cracked.
So, okay, I mean, there was like a microcosm of what this looks like, though, that happened to the US in 2012. So basically what happened is the US had put a backdoor in an encryption algorithm that was deployed, and then strangely that backdoor was deployed on DoD networks, which I don't really understand why this was. But at some point, someone else swapped the keys in the backdoors, presumably China. Swapped the keys in the backdoors, and then there were a bunch of BGP, like networking level attacks, where they were collecting the data, and then they were able to decrypt it because they had the backdoor. So presumably this was all China, and the consequences we saw were like a lot of basically the entire CIA network within China got completely unwound, and like various other sort of consequences occurred, but like, society as a whole survived and was destabilized. I imagine that's like rough, like the US and China having access to quantum computers and like decrypting whatever they've stored is going to be like that plus like maybe like 5x, not society reshaping.
Yeah, I mean, society at large, I think actually it won't really matter. Because like, especially also with the rise of AI, like there's not going to be a single real video or picture of you in existence in like 5 years from now. Because no matter how much the safe AI people want to convince us that they are definitely not going to be used to generate like compromising images of people, they will definitely exist. And so like essentially in 5 years you can't tell what's real versus what's fake anymore. So like the observability problem is clearly there. Like you just have a ton of random garbage in the world and no one is going to care. I think like the quantum security actually mostly comes down to like, can we secure comms infrastructure and can we secure economic infrastructure? Like cat pictures or like pictures of yourself, like I think for all of this is honestly won't matter as much.
All right, let's switch to the economic infrastructure. So, I mean, we mentioned banks, obviously blockchain. So let's start with the question of du jour, which is, let's say Bitcoin has a proposal to upgrade to post-quantum security based on NIST recommendation. There are going to be a number of addresses which are not going to upgrade for a variety of reasons. I mean, Satoshi being one, presumed dead, but also there's a lot of people who just lost their coins, lost private keys, etc. And so, what do you think should happen?
Could we just say, like, how incredible it would be if Satoshi upgraded his quantum keys?
That'd be so funny.
Yeah.
Like, what would that spike the price of Bitcoin or crash it?
We'd be cooked either way, really.
Yeah, you have to, I think so assuming Bitcoin could get its act together enough to deploy some type of quantum resistance and get people to migrate prior to something happening, the only option is to burn the Bitcoin. I think anything, or you consider a donation to Google or IBM or whoever builds the quantum computer. But I don't think there's any other option that could exist because you could never have a claims mechanism that would actually be verifiable.
Like, Bitcoin may have, like, it'd be interesting to see what kills Bitcoin first. The economic model of Bitcoin itself, i.e. like the issuance model, or the quantum computing risk. And I think just like people that think like, oh, Bitcoin is like a store of value for the next 20 years, I think are delusional, quite frankly, because like there's I think no realistic way in which you can upgrade Bitcoin in a way that like doesn't fully break social consensus. And if you already do that upgrade, you may as well also then try to fix the economic issuance problem at the same time.
And scale as well, why not?
Just move it to proof of stake while you're at it.
Well, I mean, Bitcoin does have a scaling problem for anything because all the signatures are much larger.
Yes.
For any.
Well, that's the thing. It's an interesting point that signatures for post-quantum are larger, but Bitcoin is kind of naturally slow, and so if they just say like, yes, there's going to be X bytes of the useful stuff, and then whatever, 10 megabytes of signatures. 10 minutes is still fine to propagate that. So Bitcoin is actually the least affected by the problem of scale.
We're going back to block size wars now.
Yeah, it's just the previous holy war, trauma.
It's a second crusade.
So I guess like within this, the interesting question for chains who are trying to scale, right? Right now, upgrading to post-quantum is actually a very detrimental because, I mean, for relative, it's about 1,000 times larger signatures than what we have right now with ECDSA and Edwards and curve. And so you effectively, I mean, not 1000x slowing things down, but like dramatically slowing things down on bandwidths and, some of the computation. And so kind of an interesting question is like, what is a trade-off should be for chains who are scaling or who are trying to aim at that?
Every chain should have a credible strategy and ideally working tech demo in place by at least the end of 2027. It is in no one's interest to upgrade prior to like Q-Day. And so I imagine the only because like we've seen this time and time again, prioritizing security over performance loses you the market 99 times out of 100. And so having like a big blue, is quantum blue, a big blue button ready to go that you just like hit when like that moment occurs, that maybe there's already been a vote that says like, hey, the foundation has the authority to hit the button and have that upgrade happen. But it really is one of those moments where there's gonna be one chain hacked first. And then at that moment, everyone else says, oh no, and like does the upgrade. But yeah, I think that the game theory, unfortunately, is a governing the commons problem that doesn't support anyone preemptively upgrading who has a performance-focused architecture.
I think, so there's multiple stages to this process. So the first stage is having some kind of account type on your chain that once you move funds into those accounts, if all of the quantum vulnerable cryptography was disabled, you would still have access to your funds, right? I think that's deploying those upgrades by 2027 is, I think, sort of table stakes right now. It's shocking to me the variety of different chains that actually seem to be working on this. I was like very pleasantly surprised that the like Dogecoin developers are working on this. Like I didn't really know that there were Dogecoin developers, but it turns out they are, and they do seem to be working on this, which is interesting. But then there's the hard decision is the upgrade that disables the pre-quantum stuff.
I would actually argue that like on the user side, it's not even that critical. Well, it's critical, but the more critical part is validators. Like validators really have, because you have some amount of slashing window, ideally, like where your light client proofs are still valid, and you really need to have the ability to like upgrade kind of like 4 weeks in the past in order to securely upgrade the chain. So especially like on the securing the chain, I think you need to move much earlier than sort of everything else. On the user space, you can kind of wait, but on the actually underlying security model, you really have to move early. I think so. Two things. One is we really need better hardware acceleration for post-quantum signature schemes because like HTTPS arguably took off because we had good in-chip accelerations for like ECDSA and like signature algorithms there, which made it cheap to compute on normal phones. And this is actually going to be a problem like just like computing signatures on your phone. And the other aspect is maybe if we can get to a ZK circuit, like the bandwidth problem is true, but like ideally we can just have a circuit that attests that all the signatures are correct, and then we don't have to ship all these signatures around. We just like attach a proof to a block, all the signatures in the block were correct, and we just ship one proof around.
Yeah, but for that you need post-quantum circuits first.
Oh yeah, I mean, it's purely a trade-off between bandwidth, compute, and like how good we can get on ZK.
I mean, I have no idea. Is there any post-quantum ZK?
Yeah. No. So like Starks are all hash-based.
post-quantum? Okay.
So they're
Starks.
post-quantum. And then there's the lattice-based zero-knowledge proof sort of genre has also actually advanced quite a bit in the last, year.
The challenge is still making it performant enough. Like it works really well on beefy machines. Like making this work in like user space on phones, very difficult.
The Ethereum Foundation is doing really good work on this, and like Justin Drake has been really fantastic on this, and so like it seems like if you build like a custom zero knowledge proof system rather than like a ZK VM and then do it's like starting to approach the desired level of performance.
All right, so we have some credible post-quantum upgrade by 2027 where, if you have your cold storage, you can move in there. You have let's say, ZK proofs, so we can compress the signatures to not transmit, 100 gigs of just pure signature data. I do think the validator part is the more important because you need 400 millisecond, 200 millisecond block time. You need to sign that. You need to propagate that. So there's challenges just around that. But indeed, validators may have just a better accelerators on their compute.
Yeah, I was going to say, we are seeing validators get heavier and heavier in pretty much every ecosystem. Even Ethereum is talking about heavier validation now. So I think the idea that in 3 years, everyone's got to buy an $8,000 acceleration card for their validators. That's not actually a barrier, right? Even if you've got 1,000 validators, that's like a pretty trivial amount of money for most of these blockchain foundations at this point. It's real money, but it's a tractable problem in a way that if we have to do that in the user space, it's much harder.
Yeah, because we've seen this with the Ethereum Foundation trying to do the entire VDF thing and build custom hardware and then ship this to all the validators. Building custom hardware is really, really difficult. And I'm worried that we shouldn't really, if we just buy beefy CPUs, we're probably fine.
I don't think it's going to be custom hardware that crypto creates. I think we're going to see the same way that you had a sound card for a while, right? And now we're basically just in a graphics card. But you could potentially, this is FPGAs, potentially these are other types of ASICs, but this is one of the few problems that crypto doesn't actually have to solve. It's very important for this industry for it, but there's going to be so much money already put into this in defense applications and national security spaces. You can imagine that this is going to be an area that there are a lot of people writing a lot of checks for over the next few years, and that the hardware acceleration card, the same way that the AI folks did not invent the GPU, they simply took CUDA, which was not built for AI workloads at all, and that turned out to be a really great way to run AI workloads, and now we're off to the races. You could see something very similar happening where there's other technology that the NIST is developing, that other places are developing. There's a lot of, there's probably at least a 10 million unit market for a piece of custom hardware that does this type of thing.
Well, and I think, to your point, this is just going to become part of the standard CPUs going forward because, your Instagram and your instant messengers will need to also have.
But on the other hand, I have so much trauma from trying to as an industry just aligning on crypto primitives, for validator, HSM, cloud support for our industry has just been was a complete nightmare. Do you pick SecP? Do you pick Ed 25519? Lots of other key signing algorithms have come and gone. for various reasons. Our industry has been terrible at converging on like a single set of choices. And like I don't see any scenario in which we do that much better.
Okay, so
No,
here's
I think you should just build the takeaway from the entire ZKVM wars and the cryptography wars is just like never build your systems with specific crypto primitives in mind. Just generalize it so you can swap out the next best thing when it comes around.
yeah.
Never believe in standardization, essentially.
So my maybe contrarian take here is the reason the crypto industry is bad at picking standards is they don't matter. That like ZK was not an urgent problem that needed to be solved by a specific date. All the signature stuff was not an urgent problem. It was like Linux file system wars. It's just a bunch of like nerd sniping for like very small changes in actual output. And like if this is an existential thing, there's going to be big arguments about it, but we're probably not going to be picking between 14 different options.
But how many post-quantum NIST certified? Like there's like at least 4, right, already. Yeah. And so like we already like, I mean, for example, we want to do by 2027 a credible solution.
Doesn't mean we can't change
Support
it.
all of them, or
But
And
just
like,
support
well,
all of them.
almost all of them. I mean, another problem that we have is like that the NIST standards are not super suitable for the secure enclaves that we currently use in hardware wallets, right? So this is another. The Wedger wrote a good article about this. So people are now talking about tweaks to the NIST algorithms to like sort of have things that can like fit in a ledger today. It's
R1, K1.
It's bad. It's bad. Bad.
All right, so given we only have a few minutes left, let's leave with some optimistic note. So yeah, I'll let you guys. Yeah, what's your optimistic outlook? Why this is great and the world will be amazing after quantum?
So there was a like one of the biggest I think other challenges that have existed with quantum computers is there has been like a long search for something useful for quantum computers to do other than just like break all our cryptography. There was a recent, I think UC Santa Barbara paper maybe about like using a quantum. So quantum computing for sort of any sort of machine learning application always seemed out of reach because like yes, like okay, if we could like load like all the tokens on the internet into a quantum computer, like that quantum computer is like way larger than we'll break all the cryptography. But like this is not going to exist anytime soon. But there was I think a recent paper about how you could like incrementally load tokens into a quantum computer and then use it for machine learning. So I think that's really exciting. I think it's going to be really exciting if we start finding more actually societally beneficial use cases for quantum computing. And I'm starting to have hope about it unlocking actually like positive benefits. The other one has always been chemistry and simulation of that, and like having really good like photosynthetics or photovoltaics and stuff like that.
Like we should be all very excited about quantum computing, I think. Practically, just simply for the chemistry, material science, and like protein folding applications, which will make drug research probably 100x cheaper and faster. So we should all be very bullish. And like honestly, maybe it's a good thing. Maybe Bitcoin existed to put a bounty on a faster quantum computer, so we get earlier protein folding, essentially, like to better humanity. And maybe we take the sacrificial hit on Bitcoin, which
That was Satoshi's master plan.
Exactly. Overall, though, like I think especially in crypto as an industry, we sometimes tend to be delusionally terrified of the future, and we're always like over panicking. Like overall, as humans, we tend to be able to like at some point these problems come, and then we start solving them, and like 5 years later, everyone goes like, I don't even remember we were all so worried about it. So I think sort of a similar thing will also happen, and this is particularly true in crypto. I think like we tend to be very worried about the world collapsing all the time. And so I think over time, we'll just get to a decent conclusion. 5 years ago, we laugh about it. We got nice protein folding. So I think none of us should be too stressed about it.
Yeah, I mean, if the cost of testing goes to functionally zero, which is really what we're talking about, the cost of simulating and testing goes to functionally zero, I think there's huge amounts of implications for public policy. like the amount of debates we have now around what is this legislation going to do? What's the economic impact of raising or decreasing a tax rate or creating this carve out? Like the bull case for this stuff is we will now get like reports that give probabilities across various outcomes in ways that we don't have currently, and we can actually make the act of public policy as efficient as the act of like hard science. I think that would be very cool.
So quantum government.
Yeah. Quantum-enabled government.
Backed by quantum secure Bitcoin.
Fund it, fund it. Yes. All right, well, I think it was great. Thank you very much, guys. I think sounds like we're not completely effed. There's a lot of optimistic, there's also just a lot of work to be done to really prepare and upgrade, but all in due time. And then Bitcoin will just need to figure out its, is it wants to move with the time or be forgotten in a quantum decryption. Thank you.
Thank you.
Thank you.